Hey everybody, this is Longo here, and this is another video on proving trig identities. And what we're going to do in this one is cover some different ways of proving. The first video was a little bit of an introduction. This one's going to have just a few manipulations that you need to be aware of that could happen. Now again, this is just math stuff. It's adding and subtracting fractions, it's distributing, it's factoring out GCFs, just with trig identities instead of numbers and the letter X, okay? So, first example, old school distributing. You can distribute that cosine X and some magic might happen in a little bit. Remember, work from one side. So that's going to give us cosine X tangent X plus cosine X sine X cotangent X. And that's equal to our sine X plus cosine squared X. Okay? Next, we can rewrite tangent as sine over cosine. So that's going to give us cosine X, and tangent would be sine X over cosine X, plus cosine X, sine X. Cotangent can be cosine X over sine X. And now you can see we can just cancel this cosine with that cosine, and we can cancel this sine X with that sine X. Now the top of this one, we are just left with sine X plus cosine X times cosine X is cosine squared X. And check it out, we're done already. So it's, again, sometimes it's a little bit tricky, but it really isn't that difficult. You know what I mean? Like, just keep going with it. Not bad. As long as your math is true and you're not making up new maths, you're probably fine. Okay? What did we talk about in one of the previous videos? Adding and subtracting fractions. You need to have a common denominator, but remember, common denominator, you have to multiply. You can't just say, oh, I can, add two cosines to this and it'll turn this one into a positive. No, you can't do that. So these go together. So if I want to get a common denominator, this side needs to be multiplied by 1 plus cosine X. And this side needs to be multiplied by 1 minus cosine X. And then your denominator will be 1 plus cosine X and 1 minus cosine X. Okay? So after we do that, we are going to have 1 plus cosine X plus 1 minus cosine X all over the common denominator of 1 minus cosine X times 1 plus cosine X. And of course, equal to 2 cosecant squared X. On the top, you can see that we have a positive cosine X and a negative cosine X. So if we cancel those two, that's where we're going to get our 2 over. But the bottom, we can FOIL that. Old school foiling. So 1 minus cosine X times 1 plus cosine X. 1 times 1 is 1. 1 times a positive cosine X is a positive cosine X. Negative cosine X times 1 is a negative cosine X. And negative cosine X times a positive cosine X is a negative cosine squared X. Old school math. Check it. Boom. Positive and negative cosines cancel. So your denominator is now 1 minus cosine squared X, and that's equal to 2 cosecant squared X. Pythagorean identity. 1 minus cosine squared is sine squared. So we now have 2 over sine squared X is equal to 2 cosecant squared X. And 2 divided by sine squared X, the reciprocal of sine is cosecant. So again, reciprocal identity, boom, you are done. Okay, that's it. Not that bad. Take it one step at a time. Next guy over here. Secant squared X plus cosecant squared X minus the quantity of tangent squared X plus cotangent squared X equals 2. Okay, people, this one I can tell you right now can be done in multiple different ways, but it all depends on which Pythagorean identity you notice first. So, secant squared x. We can write that as one of our Pythagorean identities of tangent squared x plus 1. And then we have plus cosecant squared x minus, and then of course you see that you have a tangent squared x, which is going to disappear as we distribute this. But cotangent squared x can be written as cosecant squared x minus 1. Okay, and that's all equal to 2. And now, as you distribute, so if you distribute this negative in here, you're going to have tangent squared x plus 1 plus cosecant squared x minus tangent squared x minus cosecant squared x plus 1 equals 2. And now, tangent squared and a negative tangent squared, they cancel. Positive cosecant squared, negative cosecant squared, they cancel. 1 plus 1 is 2, and that's equal to 2. And again, you're done. Just manipulations. Okay? If you would like, if you feel confident by now, go ahead and try number 4. Just get a common denominator and add those together. If not, here we go. Our common denominator is going to be cosine times 1 plus sine x. Don't distribute that right now because it might factor out. So over here we had to multiply the top by 1 plus sine x, and we have to multiply this guy by cosine x. Remember, 1 plus sine x times 1 plus sine x, you are not going to just square each term. You have to FOIL. And when you FOIL that, you are going to get 1 times 1 is going to give you 1. And then you're going to do 1 times sine x twice, which is going to give you plus 2 sine x. And sine x times sine x, you should have sine squared x. Plus, you have cosine x times cosine x, which is cosine squared x. And you should recognize sine squared x plus cosine squared x is a Pythagorean identity. So your next step is 1 plus 2 sine x plus 1. And that's divided by cosine x and 1 plus sine x. Still equal to 2 secant x. And we know that 1 plus 1 is 2. So that's going to give us 2 plus 2 sine x over cosine x, 1 plus sine x. And over here, one of the things you learned back in the day is factoring out greatest common factors. These have a GCS of 2. So factor out a 2, leaving you with 1 plus sine x is over cosine and 1 plus sine x. That's leaving you with 2 secant x. Now notice that the top and bottom is 1 plus sine x, so we can cancel those. So 2 divided by cosine x is one of the reciprocal identities. So that's going to turn into 2 secant x is equal to 2 secant x. Okay, I had to go this way because I ran out of room. But anyway, that's a second video on solving trig identities. A step above the first one, but still, you know, these are not too crazy. All right, that's it. Trig Identities Part 2. This is Longo, and I'm out. See you, bye.